Welcome to the Internet of Things Platforms module. My name is Sara Blanc. I'm going to introduce you to the world of the Internet of Things, usually referred as the IoT. This module is a step forward in your learning. We choose Internet of Things as an edge-cutting technology that can form part of your project. You must consider this module of intermediate difficulty. Thus, to follow it and success, we recommend at least a basic level in programming. If you haven't such a level, don't worry. Use this module to get a general view of how technology could be implemented in an active way in your school gardens. There are four main areas you need to know about the IoT. First, we need a kit for education and tools for coding. We choose Arduino IDE, but there are several options on the market suitable for education. Second, the cloud, where you will upload your data, this being the values read by the sensors. Of course, you need some order in your code, which we call semantics, while syntaxis means how messages are built for sending data. Finally, you need a tool to display the data. Depending on your informatics skills, you can either develop your own app, of course, or use web resources offered by third parties. The Internet of Things is useful to interconnect things around the world. Things are small devices or sensors and actuators such as those you can use for educational purposes. So, our objective is to connect these sensors with an ad hoc app or with a simple configurable platform in the cloud to display the data received from these sensors. A thing consists of a microcontroller and usually various sensors and actuators. The microcontroller is the brain of your system. Smartphones, computers, TVs, or washing machines are examples of devices with a microcontroller. For example, in our garden, the microcontroller reads the measures obtained by the sensors and sends the data to a cloud platform. So, we need a microcontroller to program sensor reading and sometimes actions such as opening or closing an electric valve. There are several useful kits for education on the market. We have chosen Arduino, but there are many others. With sensors, we differentiate between analog sensors and digital sensors, some of which require a specific protocol, such as I2C or SPI. Regarding the cloud, it has two functions. First, the cloud provides you with a database to store the measurements from your sensors. There are many IoT platforms and some have economical advantages for educational purposes. Secondly, some platforms allow you to add visual representation of data. Nevertheless, this is optional. If you have informatics skills, you can develop your own app. For example, we propose Google Firebase as a real-time database in the cloud. The app has been developed with Android Studio and connects the Firebase with Flutter. Finally, we add some graphical enhancements with the Syncfusion library. Finally, communication itself involves two important issues: semantics and syntaxis. Semantics is the way of describing the information inside a message, and syntaxis is the format of the message, for example, JSON or XML. As you have seen, the scope of an IoT project is very wide. You will have to make decisions about different platforms and how to combine them. But the most important thing is to organize the students' work well and the structuring of the information to avoid making unnecessary changes during the term. To learn more, in this module we offered you 3 practical exercises. For the first, we proposed you use Arduino Nano IoT33 microcontroller with Wi-Fi chip. This exercise introduces you to the Arduino Integrated Development Environment, or ID. The second exercise provides you with some examples to build, for example, a weather station or a soil humidity proof, with the generic template given in the first practice. The third exercise is slightly more advanced. It solves the problem of long distances. For example, if the Wi-Fi signal doesn't reach your garden, we propose a star topology consisting of several Arduino Nanos, to which we will add a LoRa shield plus a gateway that acts as a bridge between the LoRa and the Wi-Fi technologies. LoRa is a radio frequency technology that allows several kilometers of range in the open file. It is simple and inexpensive. Finally, the Arduino code is available on our GitHub site. Just download the code and start with the exercises. By the end, the learning objectives we expect you to achieve with these practical exercises are: to become comfortable with Arduino IDE, to develop an IoT project using an Arduino microcontroller as an example, to get practice in using 2 communication technologies, Wi-Fi and LoRa radio frequency, to communicate your things or microcontrollers with a real database in the cloud, using Google Firebase as an example. Finally, aside from the hardware, learn how to organize your garden, both in real spaces and in coherence with virtual spaces. Thank you very much for your attention.